This is the video for warm-up number 10-6. Number 1, list the 3 measures of central tendency. Those 3 measures of central tendency are found on page 427 and are the mean, median, and mode. The measures of central tendency are referred to as the average. Usually, when people say the average, they think of the mean, but all 3 of these can be referred to as the average. Number 2, we want to list the 3 measures of variability. The 3 measures of variability are range, the interquartile range, and the standard deviation. All 3 of those tell us how spread apart the data is. We're going to use the data to make a box and whisker plot. The first thing we need to do is order the numbers from least to greatest. Okay, after we've ordered them from least to greatest, we want to find the median, the middle of the data. And that's going to be right here between 13 and 13. And the middle of 13 and 13 is 13. This is our median. Now we want to find the median of the lower half of the data. I have 1, 2, 3, 4, 5, 6 numbers here. So right there between 11 and 12, the middle of that, if I was to add those together and divide by 2, I get 11.5. This is my Q1. This is my min. Now we want to find the median of the upper half of the data. That's going to be between 15 and 17. 15 plus 17 is 32. 32 divided by 2 is 16. So the median of the upper half of the data is 16. This will be my Q3. 20 is going to be my max. Okay, we're going to go ahead now and do our number line. Okay, the left side of my box is 8. That's my left whisker. And at 11.5, that's the left side of my box. Then the median is 13. And the right side of my box is 16. And my max is 20. That's my right whisker. Okay, now it wants to know what is the minimum. The minimum is 8. What is the maximum? That is 20. What is the upper quartile? That's the same as saying what is Q3? Q3 is 16. What is the lower quartile? That is the same as asking what is Q1, which is going to be 11.5. The interquartile range is Q3 minus Q1. So we have 16 minus 11.5. And that's going to give us 4.5. The median is the middle, that is 13. The lowest 25% is below, lowest 25%, so if I was to put percents on here, this is 25%, this is 25%. So the lowest 25% is below 11.5. The upper 25% is above 16. The highest 75% is above 11.5. And the lowest 75%, right there, is below 16. Okay, the middle 50% is between 11.5 and 16. The lowest 50% is below 13. And the range is our max minus our min. So that's going to be 20 minus 8, which is going to give us 12. Okay, we're going to go ahead now and go to the next page. A company produces hard candies. The mean number of candies per package is 22. So I know my mean is 22, so that goes right here. 22. And the standard deviation is 2. So we need to fill in this chart right here. So if my standard deviation is 2, to find this number is 22 plus 2, which is 24. Then I add another 2, which gives me 26, and then another 2, which gives me 28. To go this direction, I'm going to subtract 2. So 22 minus 2 is 20. And then subtract another 2 is 18. Subtract another 2 is going to be 16. So now we can see that 68% is between 20 and 24. Okay, and that 95% is between 18 and 26. And 99.7% is between 16 and 28. Okay, a company bottles pickles. The mean weight of each bottle is 32 ounces and the standard deviation is 3 ounces. When filled by the machine, the weights of the bottles are normally distributed. Okay, so once again, we want to figure this out. So I'm going to go ahead and create this again on a smaller scale. Okay, and I know that the mean weight is 32. So 32 is right there. My standard deviation is 3. So I'm going to add 3 to go this direction and subtract 3 to go this direction. So plus 3 is 35, plus 3 is 38, plus 3 is 41. Now I'm going to subtract 3. So 32 minus 3 is 29, minus 3 is 26, minus 3 is 23. So I can see that 68% of my weights are between 29 and 35. And 95% are between 26 and 38. And 99.7% is between 23 and 41. Okay, a company produces beef jerky. When weighing the packages, quality control finds that 95% of the packages weigh between 445 grams and 461 grams. So once again, I'm going to draw my bell curve here. I'm not concerned about to scale. I'm just using this to help me kind of outline what's going on. Okay, it told me that 95%, which is 2 standard deviations away, is between 445 and 461. So the first thing I want to do is figure out what is the mean? What is the middle of those two numbers? So I'm going to add those together. So I'm going to say what's 445 plus 461 and divide by 2. When I add those together and divide by 2, I get 453. So I know my mean is 453. Now I need to figure out my standard deviation. So I want to know how far is 2 standard deviations from the mean. Well, if I do 453 minus 445, I get 8. If I do 461 minus 453, I get 8. So if 2 standard deviations are 8 away, that means if I divide both sides by 2, that 1 standard deviation is 4 away. So 1 standard deviation would be 4. Okay, our last problem. A company produces beads. Quality control finds that 68% of the packages have between 242 beads and 294 beads. Let's go ahead and draw our bell curve to represent this. So we know that 68%, which is 1 standard deviation right there, is between 294 and, oh, I need to go the other way, sorry, between 244 and 294. 244 needs to go on the left-hand side, and then 294. Okay, so I need to find the middle of those 2 numbers. So we're going to add together 242 plus 294 divide by 2, and that gives us 268. So this is 268, the mean. Now I need to know how far is 1 standard deviation away from each one. And when I do that, I'm going to do 268 minus 242, and I get 26. 294 minus 268 is also 26. Since that is 1 standard deviation equals 26, that's our standard deviation, 26.